Okay, yesterday we talked about radicals, and now we're going to start converting them. We're going to go from entire to mixed. So first of all, we have to recognize what an entire radical is. So an entire radical is when, let's see if this guy's going to write today. It's a little sketchy. Okay, so entire radicals. Looks like chicken scratch. Okay, entire radicals, they have a hidden 1 in front of the radical. That's how you know. Come on, are you freezing on me? In front of the radical. Okay, so they've got a hidden 1 in front of your radical. That's how you know it's in entire form, okay? So there's a hidden 1 in front. That guy likes to hide. Okay, so that's how we know we're in entire form, because all you've got is a hidden 1 out front. Now, we're talking about 2 things we did yesterday. So we found out that the product or quotient, so when we multiply or divide radicals, it's the same as if we do them separately or if we do them all together. So here it's saying if I take the a times the b, I get a times b. So if I had root 3 times root 5, I would get root 15. And if I checked all the decimal numbers, the left side would equal the right side. So the left side of the equal sign is what I'm talking about here. Let's just make my equal sign look like it's an equal and not unequal. Come on now. Equals. Okay, so we have left side over here. We have right side over here. When the left side equals the right side, you know you have a true statement, okay? Same thing goes for dividing. But again, they're going to tell you that A and B have to be equal to or greater than 0. The reason is because you are allowed to have 0 on the bottom of a fraction, but you cannot have 0 on the top of a fraction, okay? You can have 0 on top, but you can't have 0 on the bottom. So no 0 on bottom. So you're going to notice that they say some really strange things. We have to identify what this means. So right here it says A and B are greater than or equal to 0. That's when you're multiplying. So that means I could take a 0 times a 0, I get 0. 2 times 3, I get 6. But if one of them is a 0, that's okay, because 0 multiplies to give you a 0. However, when you're dividing, it does matter where the 0 ends up. If you've got 5 divide 0 underneath the root versus 0 divide 5 under the root, they are very different. If you try to go anything divided by 0, the calculator will stop you and say, error, can't divide by 0. So that means that's why they're saying that B, the bottom, has to be bigger than 0. And the reason it's saying bigger than and not less than, because if it's a negative, the negative will float to the top number. So the bottom number will never be negative, ever. Okay? So that's why they're saying it's got to be greater than 0. Okay? Even 0.5 is fine. Okay? But it's got to be a number bigger than 0. So that means this is not possible. That's going to give you an error. Okay? So 0 on the bottom will give you an error. So when we were dividing, we also found out that if I had a 50 on top and a 5 on the bottom, well, that was the same thing as saying 50 divide by 5 to give me an ending up as root 10, because 50 divides by 5 10 times. So whether we're multiplying or dividing, we have to realize where the zeros are allowed to be. So zeros are allowed to be everywhere except for on the bottom of a fraction. Okay? So now we're going to try a couple examples. So we're going to split number 24 up. They said, okay, you're going to split 24 by doing a 4. Well, 4 times what gives me a 24? 6. So they've split it into root 4 times root 6. Now, which one is a perfect square? The 4. Whenever you have a perfect square, you must solve it. So this one, you're going to solve it. And when you solve it, it loses the root sign. So now it's going to sit in front. Whenever it's being multiplied, right now this guy has a hidden 1. So what's going on right now is that 2 is multiplying to the 1. So 2 times 1 is 2, and then your root 6 will just slide beside it. So now what we've done is we've converted square root 24 to a mixed radical. If I put and check this guy's decimal and I check this guy's decimal, it's going to be identical. That's how you know you did it right. So the first thing we have to recognize is whenever we're trying to break down a large number under a root sign, your large radicand, you need to divide by perfect squares. So that is the key. Divide. Oh, come on. Oh, no.
That's rough.
That is really rough. Oh, my. Holy, I know. Looks like the pen is drunk. Divide. Oh, no. By. Perfect. Ugh. Ah. I know. Okay, so we have to divide by perfect squares. That's what we're actually dividing by. So you're going to notice on the right-hand side, they've got 18. Well, 18 divides by 9 and 2. So 9 is the perfect square. So what we do is we solve the perfect square. He comes outside when we solve it. He goes to the front. He goes outside and becomes a 3. So I get 3 square root 2. So the one that doesn't reduce, the one that doesn't solve, the non-perfect one stays underneath. The one that's a perfect square, he goes out front and solves. Okay, that's how you split them. That's all it is. So now when we've got a fraction underneath, the rule is you're going to take each one and separate them. So the top gets his own root sign, the bottom gets his own root sign. So I would have a root 11 over a square root 4. And now we know we've got to solve the perfect squares. So my perfect square is on the bottom. I'm going to solve it. And it's going to solve and become the number 2. And the rest of my equation stays the same. So I still have a square root 11 on top of that fraction. Okay, so your final answer would be root 11 over 2. All right. We are now going to go back to our calculators, and we're going to see what the decimal answers give us. So grab your handy dandy calculator, and it says we want 5 decimal places here. So that means I want to see 5 digits after the decimal. All right, so grab your calculators, and we're going to go square root 80. So again, you're practicing the numbers that you are typing in. So on our calculator, oh, that's not it. This is it right here. Come on. Come on. Make it active. Come on. It just takes a minute. There we go. Sign in. You are good. All right, so now you're going to hit second x squared. Second x squared and put 80 in there. And you're going to get a big run-on decimal. So now we're going to put the answer is 8.94427. Okay, so that number, that 7, there's a 1 after the 7. The 1's not going to round the 7. You're just going to cut those other numbers off the end. Now, the next number has a number in front. So all you've got to do is write the times sign. So you're going to go 2 times root 20. So 2 times and then square root 20. Now, some calculators, you don't need to put the times sign in. Because they're sitting side by side, your calculator should know to multiply them. But sometimes they don't. So get used to the habit of writing a times sign between them when they're multiplied. So again, we're going to get the exact same answer. So this guy is going to give us 8.94427. And we're going to do the exact same thing. Go 4 square root 5. And we're going to get the same thing. 8.94427. So they are identical. Now you're probably wondering, why are they identical? And it's because what they've done is they have divided out a perfect square and put that number out front. That's what's happening. But you're going to notice that two of the numbers, they're a little different. You're going to notice one has a 20 as a radicand and one has a 5. 20 can still divide by what number? 4. So that's why it keeps breaking down. So we always want to divide by our largest perfect square. So look what happens when we don't. So this one divided by 4. So square root 4 times square root 20. And then they solved the 4. And they got 2 square root 20 because they solved the perfect square. So get used to writing the perfect square first. That way you know he solves and he stays out front. You don't have to mix and match things, moving them around. The next one again is 16, a perfect square, times 5. They are the same thing. They're going to give us the same decimal answer, only the difference is they divided by a larger perfect square to begin with. When you choose your largest perfect square to divide, your answer is going to get reduced quicker. And when we deal with math, just like fractions, we need to reduce them always. So now when we deal with radicals, you want to reduce it always. And a reduced radical is always in mixed form, so lowest mixed. So these guys here, they solved the 16 and got a 4 and then a 5 underneath. Now, what would have happened if we kept that 2 root 20? Well, let's take a look. Can we convert 2 root 20 and make it go lower? Yeah, we can. Whoa, what happened? It zoomed in by accident here. Let's just unzoom it. There we go. Come on. There we go. So if I wanted to take this one right here, I'm going to go 2 square root 20. Now 20 will divide by 4. So we're going to bring down the two perfect squares that it, or the perfect square that it divides by. 4 times 5 makes 20. Now, we want a hidden 1 out front of our number. We don't have a hidden 1, so that 2 is going to slide down. Any number but a 1 will slide down and sit in front of that first perfect square. And then when you solve that perfect square, you've got to multiply those two numbers because they're sitting side by side. So now I'm going to solve the 4. And it becomes a 2. The other 2 is still sitting out front. So this 2 comes down, but now it means they're timesing. You are multiplying those. Root 5. So that will eventually look like 4 square root 5, which is what they got here for an answer. So they showed you one of the forms that wasn't fully reduced, and then you had to reduce it more to the fully reduced form. How do I know this one is the fully reduced form? Because when you look at your radicand, you always try to divide by perfect squares. And if it divides by a perfect square and gives you a decimal, that means it doesn't work. It won't divide by a perfect square. So this one, the only perfect square below or under 5 is the number 4. Everything divides by 1, so we never use the number 1. 4 would be our first perfect square. 2 squared is 4. Now, if 5 can't divide by 4 without giving me a decimal, I know I'm done. And this guy cannot divide by 4, without giving me a decimal. So that guy is in fully reduced form. So these guys are called mixed radicals because they have other numbers out front other than a hidden 1. If it has a hidden 1 out front, it is an entire radical. Okay, that's the two different forms we deal with. So entire, where everything's out or underneath, or mixed, where you've got something out front and something underneath. And that's all we're dealing with. All right, turn your page. All right, so they may call entire radicals a pure radical. A pure radical, again, has that hidden 1 in front. Now, they're giving us our list of perfect squares on the bottom of this page. But like I said, if you want to write it on the inside of your workbook or if you want to write it on one of these so you can remember it, or something bright green so you can see it right away, and then maybe tape this to the inside of your workbook, you're more than welcome to use those. Okay, so we're going to be writing out our perfect squares. The only way you're going to memorize them and understand them better is to write them out. All right, so it's showing us that an entire radical is n root b. So n is the index. So your index is the n. All right, there's our index. Now this guy here, what do we notice if they don't draw anything? It's a hidden 1. That's how you know, like I said, it's an entire form. You've got a hidden 1 out front of all of these radicals. Whereas if you look at the guys on the right, the mixed radicals, it's telling us we have a coefficient other than a 1. So it's saying that we have a coefficient. Coefficient just means it comes in front of something. Okay, a coefficient different than a 1. Ugh. Okay, so it's anything different than a 1. It could be a -2, it could be a +4. So it could even be a fraction. You're going to notice they've got fractions out front. You've got negatives out front sometimes. That's totally okay. All right, let's go down to part 2 where we are converting them. Now, every radical can be reduced. However, sometimes we get prime radicals, and that just means that it's a non-perfect square root and it cannot be reduced. Like root 2 can't be reduced, root 3 can't be reduced, root 5 can't be reduced. All those non-perfect square roots, you can't reduce those. They don't divide by perfect squares. So the first thing you must do is you go by the index. If the index is a 2, you're looking at the perfect squares. I'm just going to draw a square. You're looking at the perfect squares. If the index is a 3, what are you looking at? Perfect cubes, okay? So if the index is a 3, we'll deal with those after, then we're dealing with perfect cubes. So these perfect squares we have to get to know very, very well. 1 to 15 we need to know. And what I mean by that is the numbers on the right-hand side. The numbers on the right-hand side are what we're going to be dividing by. Then when we divide it, we basically square root it and it becomes the number on the left-hand side. The number on the left-hand side is the number that will go outside. So let's take a look. The number 108. Well, it tells us it divides by a 3. And then they end up with a 6 out front. So if a 6 came out front, that tells me if this came out front, what was underneath? A 36, the perfect square. So that means 108 is 36 times 3. So now I separate my roots. I take my perfect root, my perfect square, and that's the one I solve. Okay, so I'm solving that one. Get used to crossing it out when you solve it. So it no longer exists. You cross it out, and now it becomes the +6 out front. So it's no longer under a root sign. It loses its root sign. That's the whole process. The minute you square root it and take it out front, it loses the root sign. It's done. So now it becomes a 6 square root 3. So now my final answer is 6 root 3. And if I checked my decimals, the left-hand side would equal the right-hand side. All right, let's take a look. If a perfect square is factored out and it's not the highest one, like we saw with that other example, we still had a 20 underneath, and 20 would divide by 4. So sometimes it might be partially finished, but not all the way. Now, in your multiple choice questions or a true-false question, you could get situations where it says, which is a partial reduction, or which one is a possibility. So it may want only a partial step, but not the whole answer. Okay? It might say, what would you divide by? All right. So now what we're going to do is we're going to reduce all three of those. So the first thing you do is I find the number 50. I look at the number 50 and I find my number on the right. Whoa. Find my number. Okay. It's right here. It's in between 49 and 64. That's where 50 is. We're always looking on the right-hand side. So now what I do is I start dividing by all the numbers above it, meaning all the smaller numbers. Because this one ends in a 0, we're going to try and divide by 25. 25 might work. And if it doesn't, then we would just keep moving up. So the first one I'm going to try and divide by is 25 because it ends in a 5. And we all know that 20 or 50 will divide by 25 twice. So the way I do this now is I draw my two spokes, kind of like prime factoring. I draw my two root signs. It matters which one goes on the left. The one that's going to go on the left is the one that's going to solve. So the guy on the left has to be the perfect square. So that means 25 goes here, and he's going to solve and become a 5. He's losing the root sign. And it's 25 times 2 that makes 50. So a 2 goes there. The 2 does not reduce. So he just slides beside my 5. And that'll be your final answer. So my final answer would be 5 root 2. So now if you checked your decimals, 5 root 2 and square root 50, your decimals would match. Okay? Now we're going to deal with the number 45. This one ends in a 5 or a 0. So I'm thinking, okay, well, 45 is between 36 and 49 on my chart. So I'm going to divide by every number above it. Well, 25 is not going to work this time, even though it ended in a 5. 25 doesn't work. But I'm going to keep dividing by all the numbers smaller. I work my way up the list. So I would divide by 16, and then 9, and then 4. And we're going to find 9 works. So we're going to put our perfect square first. He's always written first. So our perfect square is 9. And it's 9 times 5. The square root 5 will slide down. And the 9 will solve. So the square root of 9 is 3. So now my final answer is going to be 3 root 5. Okay, we're going to do the same thing to the big number 320. Well, 320 is off my list. It's bigger than the 225. So this is where you're just going to literally work your way up the list and see which numbers it's going to divide by. Typically, start dividing by numbers that are less than half. So what is half of 320? About 160. So start dividing by numbers that are less than 160 of perfect squares, okay? Now, why did I say half? Well, if it divides by 4, less than half would be easier. So let's divide by all the numbers above that, and we're going to find that 64 is going to work. And again, it ends in a 0. Since it ends in a 0, the number I should try to divide by is 5. And if I divide it by 5 and get a perfect square, that helps me get my answer quicker. So it's going to divide by 64 times 5. Now, if I divided by 5 and didn't get a perfect square, then I would move to the next perfect square number and start dividing. So which number is not going to change in this one? The 5. So root 5 is not going to change. However, the one that's going to change is going to solve and lose his root sign. So 64, cross him off. He's solving and becomes an 8. 8 root 5. And if we check our decimals, the decimals are going to match exactly. All right, turn your page. Pardon me? You're good? Okay. Now we got to make the rest of these in simplest form. What makes these ones harder than the first 3 questions we looked at? What makes these guys harder? Yeah. Yeah, there's a fraction. That one, everybody freaks out on fractions. What else do you see? They're already solved or partially solved. They've got numbers out front already. Well, is that going to change things? Well, it's going to change things a little bit. So the minute we see a number out front, we're going to just make it slide all the way down until we solve our perfect square. When we solve our perfect square, it's going to multiply to his answer. Okay, because sitting side by side means multiplying. And that 2 out front is multiplying. It's being times by that root. So this guy's just going to slide down. And then I'm going to break 192 off. Now 192, again, I'm going to start dividing by perfect squares. So I'm going to divide by 81. I'm going to divide by 64, 49, all those perfect squares. And we're going to find 64 works. And again, a lot of this is guess and check. 64 times 3. Okay, so what 2 numbers multiply to give me that number? 64 times 3 does. Which one of those is my perfect square? Good, I wrote it first. Why did I write it first? Because he's the perfect square, and because he's then automatically sitting beside the one that's already there. And then when you've got 2 numbers sitting side by side, that reminds you to multiply them. So that's why we put the perfect square right on the edge on the left. So that's why my 64 is going to solve, cross them off. He's now going to become an 8. The 2 still slid down, and now I put a times sign between them, because side by side means multiplying. And then I write my square root 3. My final answer is to actually do the multiplying. So now 2 times 8 is 16. My final answer will be 16 root 3. And again, to check your work, check your decimals and you'll be fine. Now, if you're confused about what that means, I'm going to show you real quick. By checking your decimals, I mean write your original in. So I would go 2 times square root 192. I get my decimal answer. Now I put my answer in that I got. 16 square root 3. Whoops, not 6. 16 square root 3. And it's going to give me the exact same decimal answer. That's how I know I did it right. Now, multiple choice questions in your tests. A, B, C, D, they're all in mixed radical form. What is an easier way to see which one's your answer? Turn them all to decimals and see which decimals match the one they're asking about. Okay, so your calculator can do almost this entire exam for everything. You just have to know how to run your calculator properly. All right, back over here. So now 3/4, it's a fraction already. That's okay. We're going to leave it as a fraction. He's going to come off to the side, and then we're going to split 160. And he's timesing to the roots. Now 160, we automatically know because it's got the number 16 there and a 0, it'll multiply by 16 and 10. Everybody catch where I'm going with that? Okay, and does 10 reduce? If we look at our perfect charts, I'm just going to write 16 and 10 so I don't forget. Come on. 16 and 10. Let's look at our perfect squares. If I look at 10, 10 is right here, just under the 9. If I divide by 9 and 4, we don't check 1 because everything divides by 1. But we would check 9 and 4. And 10 won't divide by 9 and 4 without giving me a decimal. So I know that it doesn't work. So that's how I know that square root 10 is my final answer. So now I got to deal with that 16. What is the square root of 16? 4. But there's a fraction sitting beside it. So that means I need to put it out as a fraction. How do you put any number into a fraction? Put a 1 on the bottom. So my 16 ends up becoming 4 over 1. And out front, I've got 3 over 4. And they're timesing. So I would times your top to top, bottom to bottom. And again, this is all sitting beside square root 10. So now you're multiplying top to top, bottom to bottom. So these two multiply, and these two multiply. Well, you're going to get 12 over 4. And sometimes they're going to divide evenly and give you no fraction answer. Well, 12 does divide by 4 3 times. So this right here is going to turn into just a 3. So my answer will be 3 root 10. Okay, once you actually figure those fractions out, it's going to turn into 3 root 10. Well, hello. We have a delivery, do we?
Yeah.
Who's the delivery?
Jordan T.
Oh, Jordan T. Can you take it to the back table and give it to her? All right. She's in the purple.
Here, Billy.
Thank you. All right. Okay, moving on. All right, letter C. Yeah. When we've got a fraction, we need to split the fraction into top and bottom separately. So square root 7 on top of square root 9. Square root 7 on top of square root 9. All right. Now that's going to become, which one is a perfect square? 9. Good. Now we have to solve that 9. He's going to lose his root sign. What does he turn into? A 3. Good. So this becomes root. Whoa. I know. I don't even ask. This thing glitches out like I have no idea. It's on a totally different wavelength than I am. Okay. Root. Come on. 7 over 3. Now what number is hiding in front of that 7? A hidden 1. So that's actually going to turn to a fraction and look like this. 1/3. What? What? I don't know what I just did. Okay, pushing play. Come on now, pushing play. Oh my good Lord. Come on. Yeah, right. There's a hidden 1 there. So we're going to make this into a fraction, and it's going to look like 1/3 square root 7. That's what it's going to turn into. 1/3 square root 7. Okay, so anytime you get a digit on the bottom, it can slide over to the side and create a fraction. And it doesn't matter what number's in front. That could have been a 55 in front, and it'd be 55 over 3 in front. Okay, so it doesn't matter what number's sitting in front. In this case, it was just a hidden 1. Okay, last step here. This one wants to do the opposite. Now we're going to take the guys that are out front and we're going to put them underneath. Okay, so we're doing the opposite now. Now we're taking all of the numbers out front. We're making them go under. So what's the opposite process of square rooting? Squaring. Good. So in order to take a number under, it's already been square rooted. So what you do is you use the index as an exponent. So that means the 3 is coming under as with the index as an exponent. So the index is used as an exponent on the number you're bringing in. On the number going under. Oh boy. Hopefully you can figure that out. That looks a little crazy. The index is used as an exponent on the number that's going under the radical sign. So now we're going to solve 3 squared. 3 squared becomes 9. And now you're going to multiply 9 times 14. And we're going to get square root 126. So again, if we check their decimals, the decimal answers would match. So whenever we're taking it to an entire radical form, we always want it to end up with a hidden 1 out front. We don't want anything else but a hidden 1 out front. That's how we know it's an entire form. So let's do a couple practice questions. We're going to take these guys underneath. So to take the 2 underneath, I'm using the index, which is a 2. So it's going to look like this. 2 squared times 5. So that's going to be 4 times 5 is 20. Okay, so that guy is going to end up as square root 20. This one is going to be 4 squared times 7. Now, if you don't want to write the squared sign, you could just go 4 times 4, okay, or 2 times 2. It's whichever you prefer. And that's going to give us 16 times 7, which is going to give me 112. The last one there, 10, to bring him under, is going to be 10 squared times 6, which is 100 times 6, which is root 600. Now we're going to take the next few. We've got fractions and decimals. We have to take them under the exact same way. Okay, nothing changes. However, when it's a fraction, you're going to square the top and the bottom. You don't just do one, you do both. So when this guy goes under, you're going to go 3 squared over 2 squared, all times 8 over 1. You need to change this guy into a fraction. So convert to fraction. By putting a 1 on the bottom. Now, you could also write it like this. 3 over 2 times 3 over 2 times 8 over 1, because that's what's actually going on. So you're going to go 3 times 3 times 8, which is going to give you 72. And then on the bottom, 2 times 2 is 4, so you're going to get 72 over 4, and that's going to combine. 72 divides by 4 18 times. So you're going to get 72 over 4, which becomes square root 18, because 72 divides by 4 evenly. Now, if it didn't, you would just do a lowest term fraction. You would just go math frac and leave it as the lowest term fraction underneath. Okay, B, it's a decimal. Nothing changes. Everything stays the same. So I'm going square root 4 squared times 50. I'm going to put a times sign instead of a dot because I'm using a decimal there. Remember, those big fat dots in between numbers actually mean multiply. But when I've got a decimal number, I'm going to use an X. All right, so now we're going to go 0.4 squared. That's going to be 0.16. So now I've got 0.16 times 50. And you literally just do that in your calculator, and that's going to give you 8. So square root 8. So 0.16 times 50, if you do that, you're going to get an 8. Now, with negatives, negatives stay out front. They don't go underneath if it's an even index. So we have to remind ourselves, even index means negatives stay out front. So the only thing coming underneath is the 5, not the negative sign. So this guy's going to look like this. Negative. Okay, the negative sign's coming down. And now under my root sign, whoa. What? I'm going to have 5 squared times 7. Well, that's going to give me 25 times 7, which is 175. 175, and the negative is out front. All right, we have 2 last examples, and then I'm going to give you some time to work this out. No, Pythagorean theorem. Ew, I know, it's getting good. We're getting good into the nitty-gritties here. Look we got a triangle coming up. Yeah. Triangles mean we have a squared, b squareds, and c squareds. Hello, you're back. Okay. Again, we are going to put these guys in order. When we put them in order, there's 2 ways to do it. Okay. The first way is convert them all to entires. So that means take the guys that are outside, put them all under. So convert them all to entire, or just make them into decimals. Decimals is the easiest, but you have to write down 2 ways. So first way, convert to decimals. Whenever it wants you to put them in order on a number line, least to greatest, or sometimes they say greatest to least, they might reverse it on you. Whenever they're asking you to order them, that means they got to be converted to decimals so you know where they belong on the number line. Or you convert them into entire radicals. That's the second way. Or convert, because you could get a multiple choice question or a true false where it says, does converting them to entire radicals help you order them? Yes, it does. Convert to entire. We're going to do the easy one. I want you guys to convert them all to decimals. Okay, I'm going to give you a couple minutes, and then I'm going to put up the entires for you. So I'll put the entires up, and we'll see which ones go where. So this guy becomes root 45. Root 15 doesn't change. He's got a 1 in front. This guy becomes 32. That guy becomes 128. So this guy should have given us 6.708, and it keeps going. This one's going to be 8.66, etc. Root 15. Whoa, not that. This one is 3.87, etc. Root 32, 5.65, etc. And root 128. 11.31, etc. Now this one wants us to put them into biggest to smallest. So if it wants us to order as biggest to smallest, which one has the largest decimal or the largest number underneath? V does, right? Number 5. It's got the number 128 and it's 11.3. So I'm going to write this guy with a 1 because he would go first, meaning he is the largest. Okay, so who would go next? Who's the next biggest number? The second one, good. So this guy is going to become number 2. Then who's next? The first one. This guy's 3. Okay, then who's next? The 4. Good. 4 is 4. And then root 15 would be last. So root 15 would be the smallest number we have there. Okay, so that's just ordering them. And again, we can do it 2 ways. Convert to decimal or to entire. All right, last example. Pythagorean theorem. When we do Pythagorean theorem, we have a squared plus b squared equals c squared. And c squared is always the hypotenuse. And that means he is across from the right angle. The A and the B are attached to the 90. Okay, you've got altitude and base. They're attached to the 90. So this guy would be a base number. This guy would be a base number. This is a hypotenuse number. This guy's a hypotenuse number. We don't have a number there though. But what is it asking us to find? It says, use Pythagorean theorem to find the exact length of A to B. So I'm going to put an X there. That's what they want me to find. So we have to find that number as an exact value and in mixed form and as a decimal. So the first thing we got to do, whenever we've got a triangle, they're going to give us 2 numbers out of 3. Well, this guy's got a joined triangle. It's bigger. So take a look. We've got 1 triangle on this side, and then we've got the little triangle on the left. They've got to give us 2 numbers out of 3 on each triangle to find them. If you're going to notice on the yellow triangle, they gave us 2 numbers. On the pink one, they did not. So whenever we've got triangles that are joined together, we need to find the line that joins them. So if I find this line right here that I'm going in blue, we'll call that letter Y. If I find that one first, then he's part of the pink triangle too. And then I've got 2 numbers to use on the pink triangle to find that third number. So this is a 2-step question. So we need to find A to D first. So that means we're using the yellow triangle. We're finding one of the legs that is attached to the 90, which means we're finding a short one. So we're going to subtract from the long one. So we're going to be going 12 squared, subtract 8 squared, and that's going to give me my y squared. Now, normally I would say put it under your root sign in your calculator and solve it. But this one wants us in exact value form, which means I have to do it longhand. So 12 squared is going to give me 144. 8 squared is going to give me 64. Now I have to subtract them to give me y squared. So 144 subtract 64 is 80. Let's be an 8, is 80. And that's y squared. Well, what is the opposite of the squared sign? Square root. So now I need to root 80, and that's going to give me y. That loses the root sign on y. Now we can solve for y. So we ended up with square root 80. We need to change that to a decimal. What is square root 80? Okay, and now we're going to break it down into a mixed radical. So 80, if I go on my chart, 80 will divide by 4, but he'll divide by bigger numbers than 4. So what we do is we take a look on our perfect squares and we divide 80 by all of the perfect squares that are smaller than 80. Okay, so what do we get for 80? 80 will divide by which number? Not 9. That's not a perfect square. We got to divide by perfect squares. 16 is a perfect square. So it's going to divide by 16 and 5. So we're always dividing by perfect squares. So 16 times 5. So we're going to solve the 16 because he's a perfect square, and he becomes 4. So 4 root 5 or square root 80 is that y number. So now I need to find a to b. So second step, find a to b. And that's on this triangle now. So now I know I've got square root 80 here. I got to find x, and on the bottom I've got a 6. We're always going to use the entire radical form. You're not going to use the mixed one. Yes, we turned it to mixed over on the left. We're going to use the entire form, and I'll show you why. So now we got to do our a squared b squared again. This time we're finding alongside the hypotenuse, so we're going to add them instead of subtract them. You're going to notice over on the left-hand side, we subtracted on purpose because we were given the long side. When we're not given the long side, we add. So we're going to have square root 80 squared plus 6 squared equals x squared. Now what happens if you have a squared sign and a square root sign together?
They cancel out.
They do cancel out. So that means the 80 stays all by itself. He just loses his signs. So now this guy just becomes 80. We have to square the 6, which becomes 36. And that equals our x squared. So we're going to add those together, and that's going to give us 116. So we get 116 is x squared. And now our last step is always to square root the answer. So I would square root 116, and we're going to get the decimal. So how big is the decimal? And it wants to the nearest hundredth. So it wants 2 digits after the decimal. So you have to look at that third one to see if the second one rounds. So what do we get for a decimal? 10.77. All right, now we need to change it to a mixed form. We're going to go mixed. I just got to get rid of all those scribbles there. Okay, so we're going to change the root 116 into mixed. So we got to square this guy off. So that means dividing by perfect squares. If we divide by all the perfect squares, the only one that works is 4. So we're going to, and that would have been a lot of them you have to try. And you'd get decimals for all except for square root 4. So it's 4 times 29. And 29 is a prime number, so he will not break down. So 4 times 29. And the only one you can solve is your perfect square. He will solve. We cross him off. We get a 2 square root 29. So our final answers, we have 3 of them. We have the decimal, we have the entire radical, and we have the mixed radical. Triple hint on your quiz, the next quiz, this kind of question will be on it with different numbers. So put a star beside it, circle it, or put a Q beside it to know it's going to be a quiz question. All right, that is the end of lesson 6.